Okay, so good evening everyone. So we're back again with another lesson. So today we'll solve what is known as implicit okay, so today we are solving implicit differentiation. Okay, so for those who have not watched my earlier videos on integration, please do so that you can be moving on the same page. Okay, so differentiation is the opposite of integration. So if you are differentiating something, let's say you have a function y which is a function of f, and you are told to differentiate this function. You can write it in this form: dy. You are differentiating y with respect to this function which has f of x. So this means differentiating a function y with respect to x. So at times the way it is, we can just write y prime. We know that we are talking about differentiating this function. At times there might be a function like this equal to ax to the power n plus maybe bx to the power m, okay, plus c. So if we say differentiate this function, it's the same as when we differentiate, we write it like this: prime. So this is just like a prime. This means you're differentiating. After differentiating, your answer will be, so this you drop down n, so it will be a n x n minus 1 plus b which is a constant here. Then we drop down m, then x m minus 1. So okay, so the simple way of looking at differentiation is reducing the power. So if we have a function f x to the power n, then we say differentiate, we write it after differentiating like this. So you drop n first, n, then x n minus 1, meaning you've differentiated. So you just subtract the power by 1. First you drop the power, then subtract the power by 1. So if, for example, y equals to x to the power 4, if we say differentiate, this is dy dx. You're differentiating y with respect to x, equal to, so you drop the 4 first, then x 4 minus 1. Okay, so meaning this will be dy dx is equals to 4x to the power 4 minus 1, 3. So you are reducing the power, that's all. That's what it means. So this is same as writing y prime equals to 4x to the power 3. So different books have different nomenclatures. So dy dx, f of x prime, they mean the same thing. So another example, let's say f of x equal to 4x to the power 3 minus 3x to the power 2 plus 4x minus 10. Okay, so we want to differentiate this function. So we write f of x prime equal to, so you drop the power here, power 3, so it will be 4 by 3, then x 3 minus 1 minus 3, which is here, multiplied by 2 the power, then x 2 minus 1 plus 4. So the power here is 1, so multiplied by 1, x, the power is 1 minus 1, okay? Minus, so differentiating 10, as long as it doesn't have anything, it doesn't have x here, we know the differential is 0. Differentiating any constant is 0. So whether it's 100, differentiating a number which has no variable is 0. So this goes to f of x prime equal to, this is 12 x to the power 2 minus 6 x, 2 minus 1, which is just x, plus 4, here is 1 minus 1. 1 minus 1 is 0. X to the power 0 is just 1. Any letter or any variable or number raised to power 0 is 1. So this will be just 4. So this will be your answer. Okay, so this is just how you differentiate. So now coming to our question, how do we do implicit differentiation? So implicit differentiation, you have number 1, 2x to the power 3 equal to 2y to the power 2 plus 5. So the way you do implicit differentiation is you differentiate each term. So this, we are differentiating this with respect to x, this. So whenever you see y, whenever you are differentiating a y term, when you're differentiating a y term, that's where you write dy dx. But when you are differentiating anything like is x, we don't write anything because we are differentiating with respect to x. This one we are differentiating with y with respect to x, so we write dy dx. Okay, so let's see. So we are differentiating both sides. There is this side and this side. Okay, so differentiating this with respect to x, we write d over dx equals to, so this we are treating it, we are differentiating with respect to what? This is y. Okay, so we are differentiating y with respect to x. So write d over dx. So you are differentiating all the terms with respect to what? X. Then here there is 5. Okay, so let's see. Differentiating this, so we say we drop 1, we drop 3 here, so we say 3 by 2, which is here, then x, 3 minus 1 equal to, so here we treat this as x, so we drop down the 2, so we say 2 multiplied by 2 y, 2 minus 1, so this is dy dx. Okay, plus this is a constant. Differentiating any constant is 0. Okay, so hope you guys have understood. So 3 by 2, which is 6, 3 minus 1, 2, so which is equals to 2 by 2, 4 y, 2 minus 1, which is just y, dy dx. Okay, yeah, so now we want to find dy dx. That's what the question requires. Find dy dx in terms of x and y. Okay, so how do we get dy dx? So you divide, we don't want this term, you divide by 4y, even here you divide by 4y. dy dx is equals to 6x squared over 4y. So you can reduce this further. 2 into 6, 3. 2 into 4, 2. This is 2y. Okay, so meaning dy dx equals to 3x squared over 2y. So wherever you are differentiating anything, as long as it has x only, we don't put dy dx. But if we're differentiating something with y, we put dy dx. That's the only secret. So like you've seen here, this one we can't put dy dx here because we're differentiating x with respect to x. So this one we are differentiating y with respect to x. So we put dy dx at the end of this function here after differentiating it. Okay, so let's go to number 2 so that you understand better. So number 2 is so number 2 we have 3x squared plus 3y squared equals to 2. So equals to 2. Okay, so same stuff. You are differentiating each term with respect to x. So this with respect to x, this with respect to x, this with respect to x. So let me write it here. Plus y squared equals to 2. So we say we differentiate with respect to x, 3x squared, plus differentiate with respect to x, 3y to the power 2 equals to, we differentiate with respect to x, 2. Okay, so the first term, this part, we are differentiating with respect to x, and it's a x term, so we don't write anything, we just drop the power. So we say 3, the power here is 2, so we drop the 2, then x, power minus 1, 2 minus 1, okay, plus, same applies here, we drop the power, so it will be 3 multiplied by 2y, which is 2 minus 1. But this is, since this is y, you say dy dx equal to, differentiating a constant, 0. Okay, so this by this it will be 6x, 2 minus 1, which is 1, so we can't write it, so just write it like this, plus this is 6, 2 minus 1, which is 1, we can't write, then dy dx is equals to 0. So we want to make dy dx now subject of the formula, so we take this other side, so it will be 6y dy dx is equals to 0 minus 6x. Okay, then 6y dy dx is equals to negative 6x. So you divide by 6y, divide by 6y. Okay, so dy dx equals to 6 will cancel, negative x over y. Okay, so this is your answer. Very simple and straightforward. Okay, so let's go to 3. Okay, 3. Number 3. So number 3 we have what? 5y squared, so 3x. Okay, let's see. Is it 3x? Oh, written 3 is 2. Okay, so this is 2. 2x to the power 3. Okay, what's the last term? Minus 5y. Okay, minus 5y. Minus 5y. Okay, so same thing. We are differentiating each term with respect to x, but here we have 2 y's, so we have 2 dy dx. Okay, so let's start. So we differentiate this with respect to x. We say d over dx 5y squared equals to d over dx, you say 2x to the power 3 minus d over dx 5y. Okay, so I've said all the y terms will have dy dx. A term which has x only, we don't write dy dx. So we differentiate this one. We say we bring down the 2, so we have 5 by the power here is 2. Then y, 2 minus 1. This is dy dx. This is y. It has y, this one. Okay? Equal to this one, no need. So we say 2, bring down the 3. Then x, 3 minus 1, okay, minus this one also have will also have dy dx. So we say 5, the power is 1, so we drop down the 1. Y, 1 minus 1, that is what? Dy dx. Okay, great. So let's continue. This 2 by 5, that is 10. Y, 2 minus 1, which is just 1, no need of writing dy dx equal to this by this to be 6x 3 by 3 minus 1, which is 2, okay, minus 5 multiplied by 1 is 5, okay. So 1 minus 1, 0. Y power 0, 1. So 1 by 1 by 5 is just 5. But here is dy dx. Okay, dy dx. So like terms, you put like terms together. So you have 10 y dy dx. This, when it comes this side, it will be plus 5 dy dx equal to 6x squared. Okay. So now we factor out dy dx here. We factorize. So if we take out dy dx, here we have 10y plus 5, okay, equals to 6 what? 6x squared. Okay. So now how do we get rid of this? We divide everything by 10y plus 5. Here divide by 10y plus 5, so that this and this cancel out. Then we'll have dy dx equal to 6x squared over 10y plus 5. So you can further simplify this by factoring out. You know 5 goes into 10 and 5, so you can say 6x squared over. So in the denominator you can take out 5. So here there will be 2y plus 1. Yeah, like this, it looks better. So dy dx is equals to 6x squared over 5 plus 1. Okay, so this is how you solve number 3. Let's go to 4. Let's check our 4. So our 4, number 4 is 4x squared. 4x squared 2y plus 3. So number 4. Is it 2y power 3? 2y power 3. Hope I'm right. Okay, wait, I'm right. 2y power 3 plus 4y. Okay, plus 4y. Okay, so here we are differentiating each term with respect to x. So same thing, d over dx 4x squared d over dx 2y power 3 plus d over dx 4y. Okay, So everywhere where you see a y term, it will have dy dx, because we're differentiating y with respect to x. So in short, we are treating the variable y as x. Okay, so let's, if we differentiate this side, we have 4, we're bringing down the power 2, divided by x power minus 1, okay, equal to, same applies here, 2 here, multiplied by the power 3, divided by y 3 minus 1 dy dx, okay, plus, so we have 4, what's the power of y? 1, multiplied by y, what's the power of y? 1 minus 1, okay, so this is dy dx. So each y term will have dy dx, that's the only secret. So 4 by 2, which is 8x, 2 minus 1, which is 1, okay, so we just leave it like this. 2 by 3, 6y, then 3 minus 1, which is 2, so this is dy dx, okay, plus, oh, here we have 4 by 1, which is 1, so 1 minus 1, 0, y power 0, 1, so we just have 4 dy dx. Okay, so same applies here. We factor out dy dx, so we have 8x equal to, so we take out dy dx, is common here and here, so we have 6y squared plus 4. Then we divide by this term on both sides, so we divide by 6y squared plus 4. Even here, divide by 6y squared plus 4. So this term and this term cancel out. Dy dx equals to 8x over 6y squared plus 4. So we have 8x. So here we can factor out the 2. 2 goes into 6 and 4, so we can remove the 2 outside. Meaning here we'll have a 3. Here we'll have a 2. So that we can divide the 2 here, 1, 2 here, 4. Okay. So meaning dy dx equals to 4x over 3y squared plus 2. This is your answer. Okay, great. Okay, great. So we continue. Yes, so 5. So 5 is a little bit different, so but we're using the same principle. So 5, we use product rule now. So 5, if you've seen, we have a term which has both x and y. Okay, so we have a term which has, so number 5. So we have 5x to the power 3 equal to negative 3xy plus 2. Okay, so we use the product rule. So product rule, the way we find product rule, if two functions u and v are multiplied and you want to differentiate these two functions, first you keep one constant, you say u, then you differentiate v, then you add, then you differentiate u, then you keep v constant. So this is the formula. If you want to differentiate functions which are multiplied to each other, so like here you have u and v, they are multiplied. Same as here you have x and y, they are multiplied together. So how do you differentiate? So you keep u first. U, you don't differentiate it, you only differentiate v. Okay, then plus. Next, here the one which you kept constant, you differentiate it. So here too, u we didn't differentiate it, so we differentiate u. Then v we differentiated it here, so here we don't differentiate it. So that's the formula for the product rule. Product rule. Okay, so this is the product rule. Okay, so now let's do this. Okay, so we can just differentiate. So we say 5 x to the power 3, so we write d over dx equals to d over dx negative 3xy plus d over dx 2. Okay, so first of all we need to solve this part. Let's solve this part first using product rule. Okay, so let's just consider this part only. So we have 3xy. So you can set n into v, n equals to, so you can say negative 3x. Let's say u is negative 3x. Okay, then if you differentiate this part, u prime is differentiating this with respect to x. Okay, so when you differentiate this, it will be negative 3 multiplied by power of x is what? 1. Then x 1 minus 1. Okay, so negative 3, 1 minus 1 is 0. X to the power 0 is 1. So 1 multiplied by 1 multiplied by 3 to be just negative 3. Okay, then v is what? Y. So we've set this first part equals to u and the last part equals to y. Okay, so we differentiate this, but remember this is a y term, so we have a dy dx. We have a dy dx. Okay, so v prime now is equals to, so the coefficient here is 1, so 1 multiplied by the power, drop the power 1 multiplied by y 1 minus 1. Okay, dy dx. Don't forget, because this is a y value, this is a y value. Okay, so v prime equal to this is 1 by 1 is 1, 1 minus 1 0, y power 0 1, so we just have dy dx. So you can write, even if you want 1 y dy dx. Okay, so we have u prime, we have v prime. So now you apply this formula, u and v, they are multiplied together. If you want to find the differential of this, you say u, if you want, v prime plus v u prime. If you want, you can say, you can start with u prime v plus u v prime. Anything you want, it's the same answer. So let's say u and v, these functions are multiplying, so we use u v prime plus u prime v. So what is u? U is negative 3x, so you write negative 3x. What is v prime? V prime is 1 dy dx. Okay, so this is multiplied by 1 dy dx. Okay, plus, what is u prime? U prime is negative 3, so we write negative 3. What is v? V is y. Okay, so we write y. Great, so say u v, this to be just negative 3x dy dx. Then positive negative to be negative 3y. Okay, so this is the differential which will be, if you differentiate this function, this is the answer. So we just put this answer when we differentiate. Okay, so as we write it, five x to the power of 3 negative 3xy okay. So this side differentiating is easy. This is just 5. We drop down the 3, then x 3 minus 1. Okay, this one has no y, so you just leave it like this. This part, if you differentiate it, we get this answer. So you write negative 3x dy dx, okay, minus 3y, okay, that's part, plus 2 has no variable, so it's a constant, it's 0. Differentiating any constant, 0. Okay, so further simplify. This is same as 15 x 3 minus 1, which is 2, equal to you see x dy dx minus dy. So we have to make dy dx subject to the formula. So we can take this guy the other side, this the other side, or we can take this whole term this side and take this guy this side, anything you want. So we say 15 x squared, this when it comes here to be positive 3y is equals to negative 3x dy dx. So you divide by negative 3x, negative 3x. Okay, so this and this will cancel out. Dy dx equals to 15 x squared plus 3y over negative 3x. Okay, so you can further simplify this. Oh, this is 15, sorry, 15 here. Okay, so you can further simplify this by taking out 3, factoring out the 3 here. So you can say 3 into 15 is 5x. So 3 is outside, y over negative 3x, so that this and this guy can cancel out. So you have 15 or 5x squared plus y over negative x. Yeah, just like that. So dy dx equal to 5x squared plus y over negative x. So this is your answer. Okay, so hope you understand the product rule. The product rule, that's the only tricky part here. So the product rule, I will emphasize again, if you have functions, two functions, y and v, if you want to differentiate them, you keep u constant, then you differentiate v, plus you differentiate u and keep v constant. This is the formula for the product rule. Okay, so let's solve the last part, question 6. Okay, so 6, so number 6 also, y and x, they are multiplying, so we'll use product rule again. Okay, so you have 1 equal to 3x plus 2x squared y squared. Okay, so first of all, we'll differentiate each term with respect to x. So we say dy dx, this 1 here, equal to dy dx vx, differentiating with respect to x, 2x squared y squared. Okay, so first of all, let's solve this part, then we combine it with these others, because this is simple to solve and this one is simple to solve. So let's take this function inside here. You have 2x squared and y squared. So let's set which one is v, which one is u, whichever you want. So you say u equal to 2x squared, this part equals to u. So meaning u prime, you are differentiating with respect to x. Okay, so this is equals to, so you dx here and this is x, no need of writing dy dx. Okay, so drop down the 2, so 2 by 2 x, 2 minus 1. Okay, 2 by 2 is what? So we have 4, 2 minus 1, 1. Okay, so it will be just 4x. Okay, so then we say v now. V equal to the last part, which is y squared. Okay, then we say we need to find v prime. So v prime is differentiating. Okay, so we know the coefficient is 1 here, so 1, drop down the power 2. Okay, then y 2 minus 1. This is y, so it will have dy dx. Very simple to follow. So v prime equal to 2 by 2, 2 by 1, 2, 2 minus 1, which is 1, so dy dx. Then now use the formula. If your function v and u multiplying, you say u v prime plus u prime v. So what is u? U is what? 2x squared. 2x squared. What is v prime? V prime is this, multiplied by 2y dy dx, plus what is u prime? U prime is this, which is 4x. 4x multiplied by what is v? V is y squared. Okay, so uv prime equal to, so we simplify this to be 4x squared y dy dx plus 4x y squared. Okay, so now we know the differential here. We know this part. When we differentiate, we know the answer. So now let's rewrite. There is 1 equals to, so here we have what? Okay, 3x. Okay, 3x. Then here we have 2x squared y squared. Okay, so differentiating a constant, this is 0 equal to, so here we drop down the power, which is 1, so 3 by 1, then x 1 minus 1, okay, plus this function is this answer here. So we are saying 4x squared y dy dx plus 4xy squared. Okay. So we further simplify it. So we have 0 equal to multiply by 1, so 1 minus 1, 0, x power 0, 1, so you have just 3 here, plus 4x squared y dy dx plus 4x yx. So we don't need these terms, we take them to the other side. So you have 0 minus 3, this when it comes here, minus this guy when it comes here, 4x y squared equals to 4 dy dx. Okay, so this is same as negative 3 minus 4xy squared equal to dy dx. So you divide by this 4x squared y on both sides. So this term and this term will cancel, dy dx equals to negative 3 okay. So we keep it clean, we can take out the negative outside, no negative 3, negative 4, so we can say negative here, then this is 3, then this is plus. Okay, like this it looks more mature, looks like at least you know mathematics a bit. Okay, so dy dx equal to negative 3 plus 4xy squared over 4x squared y. Okay, so this is your answer. Okay, so ladies and gentlemen, we've come to the end of this lesson. So thank you for watching. Please subscribe, invite your friends. Yeah, let's learn together. So thank you so much for your support. Have a pleasant evening.